decentralized applications in Flutter that. And this is basically going to be like a slightly technical presentation because I'm trying to assume that you have like a basic understanding of what a blockchain is and what a decentralized application is. You can reach out to me on Twitter after this. I'm currently working at Ignite, which is formerly Tendermint, where we basically just build blockchain solutions for businesses. So I'm mostly a mobile engineer, and I'm currently a Flutter stroke Dart GDE. That's the major thing about me, actually. So the first question we're going to have to ask ourselves is what a decentralized application is. A decentralized application is basically an application that is built on a decentralized network that consumes a smart contract or can interact with a smart contract and has a front-end facing user interface. So we have like different types of decentralized applications, but a few examples are MetaMask and crypto wallets. Basically, any wallet application is a decentralized application. There are a few other ones like OpenSea that allow you to probably publish your NFTs, or those are like very more complex examples of decentralized applications. Each and every one of them interacts with smart contracts on a low level and has either on-chain or off-chain connections via APIs or just directly connected to the to the blockchain. So for this presentation, basically, I'm just going to be focusing on the Ethereum blockchain because a lot of different decentralized applications can be built on different blockchains, but most of them are on the Ethereum blockchain. So before we jump into that, we're just basically going to see the tools that we need to build decentralized applications. So there are different number of tools we could use. There are various tools that serve the same purpose, but might give different results. But I think I've been able to streamline a few tools you could use to build out your decentralized applications using Flutter and that, and possibly you're definitely using Solidity. So these are the few tools that we'll be using. So the first one is Ganache UI. So Ganache is just, it's basically a software that emulates the Ethereum blockchain on your PC. So you can't actually download the Ethereum blockchain to your PC, but using Ganache, you can test locally on your PC without having to connect to the internet. It basically just emulates how networks happen on the Ethereum blockchain, how transactions occur, and you can easily view it through their transaction. They have like a transaction tool that helps you to view your transactions and connect to various test accounts on your local machine. The next one is Truffle. So Truffle is a CLI tool. It's an NPM package. It helps you to compile your smart contracts, basically. Using Truffle, you can compile your smart contracts, debug them, and deploy them to a test chain, if possible. Or if you need to go live, you can also use Truffle to deploy your smart contract on the Ethereum main chain. Then the next one we're going to be using is Flutter and that. This is basically the UI bit. So Flutter and that, it would just be the user-facing bits that is going to interact with the Ethereum blockchain on the back end. Then we're going to be using MetaMask as the user's wallet. So MetaMask is just a very simple Ethereum wallet. So the last one we're going to be using is Infura. So Infura is basically an API service for the Ethereum blockchain. What they do is that they provide you keys, and with these keys, you can easily access the Ethereum mainnet and testnets, and also the IPFS APIs. So IPFS is basically like a file storage system that is decentralized. Just think of it as probably a Google Drive, but this Google Drive is not stored on one user's device. So it's basically multiple people's drives interconnected into a network. For example, if you have NFTs, you can store all the images for NFTs are mostly stored on IPFS. So if you check any NFT, you would see that it does have a link to an IPFS file, and that file is what contains the data for that particular NFT. So NFTs themselves don't have this data. They only provide links to a decentralized storage such as IPFS, where anyone can actually retrieve the data inside these NFTs or retrieve the image or the videos of these NFTs. So that's what Ethereum helps us to do. So we're going to be setting up our Ethereum blockchain. So very quickly, I think I already have Ganache installed. So this is basically what Ganache looks like. So this is basically what Ganache looks like. You can easily just spin up your own Ethereum blockchain straight from this, the UI tool. So immediately you click on that, it generates multiple test accounts for you locally on the Ethereum blockchain, on your local blockchain. It basically just enables you to test locally, perform transactions between yourself without having to spend actual money on a blockchain or wait for your faucets to be credited with or with tokens or something. So for each of these different addresses, you can easily access the private keys and the address of the account. So this is useful to basically just access this test account directly from your code and manage these accounts. So we'll quickly be jumping into how we are going to connect with this application from that. So we have a bunch of different application packages that we can use to communicate with the Ethereum blockchain on that. But the most commonly used one is the Web3 DAT package. And this package was built specifically to help you connect to a Web3 client. It's basically a port from JavaScript of Web3.js. I don't know if we know Web3.js. It basically just enables you to connect to an API like Infura or Ganache, and using that API communicates with the Ethereum blockchain through the RPC, JSON RPC. So it basically creates a client, and using this client, we are able to access an Ethereum account with their private key and perform actions using that account. So once you have obtained your private key, you can easily use Web3 DAT to access that particular account from the private key and perform operations on it. So Web3 DAT has a number of different methods to it. So you can actually find out all the methods that are available for Ethereum APIs via the Ethereum wiki page. So they listed out all the different methods that you can call on via their Ethereum API and interact with it. So we have the methods to get the network ID, to get the storage, to get a transaction by the transaction hash, to get the transaction count, to basically perform transactions, to view all pending transactions, and to get the Ethereum balance of a user. So we can also easily make transactions using the Web3 DAT client. It enables us to create transaction objects. You specify the address, you specify the value. You can also specify the unit of Ether you'd like to transfer, and just perform the transaction, and you get your input locally, or you can also perform it on the mainnet. So the last bit is smart contracts. We'll be mostly be talking about this in respect to building web application, Web3 decentralized applications. So a smart contract is basically a program that runs on the Ethereum blockchain. It's basically a bunch of code that has been pre-written and that currently lives on the Ethereum blockchain. this particular block of code can execute transactions on the blockchain and give outputs to the users. So basically, it's like, well, I say like a deployed backend, but not necessarily on any server, but it's mostly just hosted on the Ethereum blockchain. So smart contracts have functions and events, and they also have states. So smart contracts can also be written in Rust and Solidity. So this is just a basic example of how a smart contract looks. This is a smart contract written in Solidity that basically just takes in a user's name, a user's email, and an option that the user has updated that email, and basically just returns the user object and saves it to an array of users. So for you to be able to write smart contracts, you first of all have to study or understand Solidity or Rust. I think there's another language that enables you to write smart contracts, but the two popular ones are Solidity and Rust. So this final bit is basically if you would want to deploy your smart contract or your definitely your smart contract to the Ethereum blockchain, or if you'd like to interact with the Ethereum mainnet or the Ethereum testnet. So Infura gives you their API keys that enable you access the Ethereum APIs directly, the Ethereum network directly, and perform transactions, retrieve data from the Ethereum network, and basically just enables you to access all the different testnets and mainnets. So that's basically my presentation, but I have more like an on-hands coding session that I would like to show you. So very quickly, we'll be creating a test application. So we'll just quickly initialize the application using Truffle. So Truffle can be downloaded from trufflesuite.com. So yeah, trufflesuite.com basically just houses the different tools that would be needing to build our smart contract. So Truffle is basically a CLI tool that enables you to write the smart contracts and deploy them. So I already have Truffle installed on my system, so I can easily just initialize a new project using Truffle init. So using Truffle init, this basically just scaffolds a test project for you with your smart contracts folder ready and migrations ready. Very quickly, I have a bunch of smart contracts that I have already pre-written. So it's so I have 3 smart contracts here. One of this is the user ledger smart contract. This basically enables you to get a user's data, like I've showed before, to store that user's data on the blockchain and easily access it later. So I've only written one function here, and that function is to update the user's data. And I have another smart contract that does a similar thing, but instead it just saves the balance of a user on the blockchain and adds it to a list. Then I have the third smart contract that basically just compiles or comprises of the 2 different smart contracts, and it basically just uses their code inside another function and houses that. So the ledger of data, it's basically a smart contract that enables you to update the user's data using the user ledger smart contract, and also just gift tokens to that same user using the update balance function. So if we were to compile this smart contract, what we'll just easily do would be to type in Truffle compile. So Truffle compile will basically fetch the Solidity compiler version for your specified Solidity version of your smart contract, and basically just update it and use this specified version to compile your smart contract. So I think it's going to take quite a while for that to fetch that. But while we are doing that, I would definitely just want to instantiate or create a new project, a new Dart project. So So very quickly, I'm just going to create. Okay. So I'm just going to create. I'm not sure why it's not compiling here, but I think it's because it's a new project. So I already have like a project that's existing that contains this same code. So I'm just going to display that instead. So when you create a Dart project, you can easily just add your Web3 package, and using this Web3 package, you'll be able to access the blockchain. So Web3 Dart gives you the ability to easily access these different functions, connect, create a Web3 client, and then you can easily extract your credentials from this private key that is given here. So for example, if I wanted to connect to this particular blockchain, all I need to do is just to copy this HTTP RPC server, and if I want to access this account, I would just copy the private key. So, yeah, so we've easily been able to access this user's account, and now we are going to get the user's balance. So we just do client. So we're going to get the balance of that particular user using their wallet address. So yeah, we've been able to fetch the wallet balance of this particular user on this blockchain using their private key, and we can also transfer Ethereum to a different user still using the Web3 client. So I'm just going to quickly write a simple function to transfer tokens. So this is a very simple function that enables you to transfer Ethereum from one address to a different address. So I need to specify the value that I would be sending. I would specify the unit also. So yeah, we've been able to make a transfer of 50 ETH from this balance to this other balance, all locally on our own blockchain that's hosted on Ganache. You can easily access the transactions that have occurred by going to the transactions tab and viewing the transaction hash. Basically just contains all the things that you normally see on a block explorer. So I believe that this is basically a very simple way to build blockchain applications or decentralized applications using Flutter and that and the Web3 library. So there are a bunch of other different libraries that will enable you add more functionality to your code and access more functions. But this is the simplest method or the simplest way to access an Ethereum blockchain or build a decentralized applications using Flutter and that. So thank you.